Hey, g'day, it's Prezzo here. Thanks for joining me in the workshop today. Hope you enjoyed that little wildlife show I just put on. The big goanna that you saw there, it didn't come in here to attack me, it actually came in to escape really. It was caught out in the open, and the local birds tend to go off if they see a goanna in the open anywhere. And the reason for that is that goannas are excellent climbers, and they will climb a tree and they tend to eat birds' eggs and also bird chicks. So the local bird population, doesn't matter what species, they do attack the goannas, or at least try to drive them off. And when it came in here, we didn't really want it in here, so I got a bit of rubber hose and we pushed out from underneath the car, and it basically took off into the paddock next door. Now, they're not aggressive. If they're cornered, they can become quite agitated, and they will defend themselves. And their main defense is their incredibly sharp claws, but also their tail, which is like a whip, and it's covered in very, very sharp scales. And they'll use it like a whip, and it can take the skin off your arm or your leg if you get in the way. They also have small but sharp teeth, and because they eat a lot of carrion, there's a lot of bacteria in their mouth as well. And a bit like the Komodo dragons, if you get bitten by one, it can get infected, and if it's not treated, it can become quite serious. Now, what's on today's menu? Well, I did say we were going to do a follow-up video on the touch DRO system for the Bridgeport mill, and I'm still doing that. I've got some items to finish off before I can show that video. And what I was planning to do is give you a breakdown in cost. But today's video is about fitting way covers to this Bridgeport mill. And the ones I'm going to show you, I bought those from eBay. They come from China. They're sort of medium quality, but the important thing is to be able to fit them to the milling machine without having to drill a lot of holes in it. So this is where I'm at with the touch DRO system so far, and in my last video I showed that I'd run the wires which are required for the power to the tablet, which is our LCD display, and also the Bluetooth adapter for the touch DRO system, and also the scales. And I'd run those wires on the back of this arm here using some 3D printed clips. And although that worked, it was really untidy looking, and the wires were much longer than I needed them. They tend to hang down underneath the arm here. And a lot of people suggested in the comments that the extra wire could go inside the arm. Now that's a great idea, except that this pivot bolt at the end of the arm here fills up nearly all of the space inside that aluminium tubing. So the next most logical solution is to run the wires in adjacent to that pivot bolt and then bring them out at various points where they're required. So at this end here, there's a total of 6 wires that need to go in through this 3D printed grommet here. And it's that shape because we've got to be able to push the USB connectors through and then turn them through 90 degrees. And 4 of those wires come out here, and they are for the 4 individual scales, and they connect through underneath here to the Bluetooth adapter. And then these 2 wires are power for the LCD and also the Bluetooth adapter. So they're just ordinary rubber grommets. I was able to push all of the excess wire inside the arm there, so it's sort of a lot neater than what it was. Alright, so when we talk about a way cover, what are we on about here? Well, this is an element on the milling machine, a knee type milling machine, which we refer to as a way. And you'll find these on lathes, surface grinders, just about any machine tool that has sliding elements will have ways. Now they are dovetailed, and there are 2 wearing surfaces. There's the actual angular part of the dovetail here, and there's this flat section here. And the saddle slides in and out along the ways in the knee, and because these surfaces fit very closely, eventually you're going to get dust and swarf and abrasive material wearing into these cast iron surfaces. And over the lifetime of the machine, that can make it less accurate, and the wear will also allow for vibration and chatter in the machining. So a way cover is just simply a method of actually keeping this shielded from any of that abrasive material. Now, on my Bridgeport milling machine, these waves are exposed at the front of the saddle and the rear of the saddle, and also the vertical section of the column is also exposed. However, the actual table and the saddle are not exposed because it's all underneath here. So it's a lot harder to actually shield all of that. I guess it's feasible, but in general, these horizontal surfaces here and the vertical surface at the back are the ones that we want to cover up. Now the real challenge here is how do we fit that, because it's got to be flexible, and also how can we do it in a way that doesn't mean we have to drill lots and lots of holes in the milling machine, which is sort of bad really. This is what I purchased to make the wave covers for my milling machine. Now I got these on eBay, it cost me a total of 77 Australian dollars, and in the kit it comes with a concertina rubber section here which is meant to go at the front of the Bridgeport knee, and this larger, wider, flat sheet which is meant to go at the back of the knee and up the vertical section of the column. Now, there were a couple of different options when you purchase these. They're all coming from China, and the cheaper ones don't have the fabric in the center of this rubber sheet. So it's a bit thinner and probably more likely to tear. So I decided to go with the more expensive option and get the one with the fabric in it. Now, when you purchase these, they come with these really flimsy stainless steel strips which were riveted to both ends of these of the concertina and the flat rubber sheet. Now, this stuff is only 0.5 of a millimeter thick, roughly 20 thou, and it's just really flimsy. And none of these holes match up with anything on a Bridgeport milling machine. So I decided to scrap those. I drilled through the hollow rivets and took them out, and I'm going to retrofit some heavier stainless steel strip at both ends. You can probably just see the remnants of these hollow rivets where I drilled those out, and they came out fairly easily, leaving a nice neat hole there, and that allows us to rivet on something which is a bit more substantial. Alright, this is what I'm going to use to replace these really flimsy strips. Now this is also stainless steel. It's 0.85 of a millimeter thick, or roughly 33 thou. It's exactly the same length as these strips, and the hole centers are exactly the same, so they match up with the punched holes that are already in the rubber sheet. And I was able to get this guillotined into two different widths. So these are 15 millimeters wide and these are 30 millimeters wide. And the idea is that we need to be able to sandwich the rubber in between the two strips and then rivet through to hold it all together. Now, because that's 3/16 of an inch, you could use a standard 3/16 pop rivet, and that would most likely work. I was a bit worried that the squeezing action of a 3/16 rivet would compress that rubber a lot before the stem broke off the pop rivet. So what I've decided to do is to make some flat-headed aluminium hollow stem rivets and then form them up using a purpose-made punch. So let's go and make a few of them. That's always the way, falls in the most inaccessible place. There's one done. That's the second operation done, just facing it off and putting a chamfer on it. Doesn't have to be terribly accurate either. In order to make the punch that forms the heads of these rivets, I've just got a bit of 10mm steel. I think it's a high quality steel, in the chuck here, and what we need to do is turn a spigot on the end of that, which is the same diameter as the hole in the center of the rivet, which is 4mm. And we need to leave a rounded shoulder. And the idea is that when the pin of the punch goes into the hollow section of the rivet, instead of just squashing it vertically, it tends to flare it out and roll it over. So we need to have a decent radius in there. What I've got is one of these brazed carbide tools with a reasonable sort of nose radius on that. And through minutes of research and development, I've determined that's the correct radius. Anyway, we'll see what happens. After I did that facing operation, I zeroed the DRO. I'm turning the shoulder back 2.5mm, and we've got to get to a 4mm diameter, or maybe slightly less. We'll go 3.96. Alright, 1.44 to go. Right, that's a pretty good fit on there. In fact, it's probably a bit tight. I might go a tiny bit smaller, and I'll put a chamfer on the end of that, and I'll just lightly polish that with some abrasive. And we don't need to harden it because these are only aluminium, and we're only going to do 12 of them, so it should be fine. Alright, I think that's going to be good. So I should mention when we start this that this flat rubber is thicker than the concertina rubber, and when I made these hollow stem rivets here I had to account for that. So these rivets that go through the flat rubber are 6.5mm from the head to the end of the rivet, and the smaller ones are 5mm. All the other geometry is the same, and all I've done here is I put the flat head of the rivet against this steel stock here, and I'm just pressing that down nice and firmly. Just want to make sure I'm not over one of the holes in that stock, and we're ready to punch that. So the idea is that the end of the punch fits into that tube, and then we just got to hold everything down flat and just gently tap this with a hammer. And that squished out really badly. That's actually split. Alrighty, plan B. Okay, plan B was to anneal the stem of that rivet slightly, so I've heated that up with the gas torch, quenched that in water, and hopefully that's going to form without splitting. Now at the end of the day, if it does split, does it really matter? Probably not. It's probably going to hold just the same. That's better. Righty, well that's way better, but rather than guess with a gas flame, what I'll do is I'll put all of these in the electric oven, bring them up to the annealing temperature, all in one batch, and that way I don't run the risk of melting these. So let's do that, and then we'll get the rest of this riveted together. I just cooked these at 290 degrees C for about 15 minutes, and that's at the lower end of the temperature range you need for annealing a 6011 T6 aluminium. But they're only thin parts. Let's see how this goes. Okay, well that seems to have worked. So you can see there it's not perfectly round, but this is the back side. We're not going to see any of this, as you see in a minute. The other side there looks quite neat, so that's what's going to be exposed. Well, there's all 4 of those done now. This is the one that we did first, it's split, but the other 3 are all good. Now the other end of this flat sheet's similar, so I won't show that. I'll come back to it later. Let's have a go at one of the concertina ends. Well, I've just gone ahead and got the strips on both sides of this concertina edge here. Now this is the way cover for the front of the knee, and there's 5 holes through the strip here, but the middle one isn't going to be used with a rivet. We're going to use that to actually hold it down to the forward end of the knee. So I'll get a rivet in this hole here, and we'll just work our way along. This one's a little bit more awkward because of the way this concertina ribbing system works, but I think we can get that okay. Now these rivets here have got the 5mm long stem because this rubber is a lot thinner. Now I've actually got to think about this a bit. I actually want the heads on this side. That one wanted to fight me, but I got it in the end. Didn't quite line up properly. If we can get one through, that's, you know, holds everything in place. Okay, now remember the middle one we're not using. We'll get one through here. Oh, it split a bit. This is the last one on that end. Alrighty, so that's what we're going to see at the front of the machine. So we'll see the flat heads of the rivets on top, and they're very low profile on the back, which is good. There's no way in the world that's going to come apart under normal use. And like I say, this center hole is going to be used to hold this down to the knee. So I'm going to go ahead now and get the other 2 edges done, and then we'll come back when we put this on the mill. Well, here's our concertina way cover already done, and I've got all the rivets in place there. And remember I said that what we're trying to avoid here is drilling any extra holes in the milling machine. Now at the back here on the saddle there's this cast aluminium wave wiper clamp, or cover if you like, with 3 countersunk head screws in it, and that normally clamps up hard against the front of the saddle there to hold the wave wipers in place. And then at this end we've got a single stop screw here. Now this is to prevent these sliding way covers from going any further than that stop screw, but that provides another anchor point that we can use. So the way this works is we're going to fit this slot over the center screw in this aluminium cover here, clamp all that up. There's a single screw hole in this strip here, and that can be clamped on that screw there, or another screw like it. So what we do is we just simply slide that into place. Like that. And then we can lift that up and get those 3 screws tight. So that's all held in place now, and then we're going to take this screw out and we're going to use a longer one. Now I've made up this little aluminium spacer here. Now the height of that is the same as the height of the dovetails, and we've got a single screw here which is long enough to go right through that and this strip here. Alrighty, so what we have now is our concertina there, held at both ends, and that could probably be a little bit tighter there. I might put a washer on top of that just to spread the load on that strip there. So that's pretty much done there, nice and neat, easy to clean that off. So let's have a look at the back one now. Right, here we are at the back of the saddle, and we've got the same arrangement of slides that we saw at the front there on the saddle, and we've got this extra dovetail slide here, which is to allow the knee to slide up and down. And we've got the same problem. What are we going to clamp to here? Now, we've got a way wiper cover in the back of the saddle that we can clamp to, but at this end all we have is this single screw here. Now, this is a stop screw. This is to prevent you from lifting the knee too high when you're elevating the knee in the saddle, and that provides an opportunity to clamp to. Now, I made this aluminium fabrication, and I'm not going to kid you, this is a blatant copy of one that was made by H&W Machine Repair. They sell a kit of concertina way covers. They call them the no drill way covers, and I looked at the price. I looked at what it was going to cost me to get it imported to Australia from the USA, and I'm sorry to say I just couldn't justify the cost. And I guess it's like the judge said that time, I had the means and the opportunity, so I just made a copy. And this is just made of 2 parts. It's held together with a couple of screws and nuts, and it's bent up in such a way that it will fit down into this recess here. So we just slide that big washer forward, and this whole arrangement just slides down like that, and it sits on top of the dovetails here, and you can clamp it up tight. So now we've got a flat surface here that we can clamp the end of the way cover to. This is the plain way cover. 4 holes drilled in that match up with the stainless steel strip, and this section on top here just sort of prevents any chips from sliding down behind that rubber cover. So by the time we finish this, we should have a nice flat surface on top. The rubber will drape down in between. So let's get it on, have a look. Right, here's the back way cover just sitting loose in there at the moment. And the way this one attaches is a little bit different to the one at the front. So what I've done is I've got a stainless steel strip here that's bent at 90 degrees. We got the 15mm strip at the front here, which is riveted on. And these sets of holes match up with the holes in this aluminium shelf here. And that's all going to bolt underneath there with some hex-headed nuts and bolts. But I'm not going to do that yet. What I want to do is get this off again, and I'll sandblast this and powder coat it, and we'll put it back permanently. Alright, there's our bracket after powder coating in satin black. I'm just going to slip that in place. I don't need that to be super tight. It's not going to come off. Okay, let's get the flat rubber sheet on. Now, I'm going to come right out and admit it. This strip here, I managed to put on the wrong way around. I put it on the back, on the sort of the matte side of the rubber sheet. And I'm happy to admit that topology is not one of my favorite areas of mathematics. Topology is the study of geometric shapes as they're twisted and bent. And I just couldn't visualize how this was going to go when it was on the mill. But essentially we need this very flat surface to go right against the back of the table here. So I'll get this hooked in place. Alright, can't see a thing. Alright, hopefully that gives you a better view of what's going on here. So this is the 15mm wide strip here sitting right down on top of that way wiper casting, and the slotted slot in that back stainless steel strip fits over this screw. It's going to firm that up, and then you just want to check to make sure it's level, which is about there. And then we can tighten down these outside screws. Now the actual way wipers are just in this area here. So we want that stainless steel strip to be behind the way wiper. Now in my case, I've made those out of rubber, but you may find that sometimes they're made of cork or felt. But you just want to make sure this is right at the back of the table when you tighten everything up, and then the way wiper will be sitting over the top of that part. I'm just trying to squeeze in around the camera here. Alright, okay, so the last step in the process here is just to slip that bracket underneath this shelf here, and I've got some 5mm socket head screws to hold that in place. I misspoke then, I said these were 5mm socket head screws, they're actually 4mm. Hey, what's 1mm between friends, eh? This last one, it's always the last one, it's just about impossible to get at. So I just slip that bracket off there again, we'll get that last nut on there. I think captive nuts would have been the way to go here. Alright, tighten that up in a minute. Alright, that's done. That's sort of not as sturdy as I would like. Now what I might do is put a stiffening plate up the centre of this, this bracket here, just to keep that tight against the column there. But there it is, all fitted up now, and I went ahead and made a stiffener piece that goes on the vertical section of this bracket. So let me see if I can show that to you. There it is there, so it's just a piece of mild steel, 5mm thick, 75 wide and about 90mm long, and it goes on top of the aluminium section. Now if you were doing this as a new project, I'd suggest you make that vertical section of the bracket out of something like 4mm steel or 6mm thick aluminium, just to give it a little bit more rigidity. But I think that's going to be okay. I also cut the corners off here at 45 degrees just to make it a little bit neater. They just sort of seem to curl around, make it look untidy. So that's all good, and I've got the table down almost as low as it can go now, just to show you that we got plenty of rubber there, probably a little bit too much. The table's not quite all the way forward at this stage, but I'm pretty sure that that's going to be fine. And the last thing I need to do is to figure out some way of protecting this scale here at the back of the table. Now it's going to get coolant and chips landing on it all the time, so I'm thinking that some sort of like a right angle aluminium cover will do the job there. And this rubber is a lot wider than the actual knee of the machine. So let me show you the other side. So over here the Y-axis scale is well protected. It's sitting underneath this rubber that comes out quite a long way, keeps all of that protected there, same at the front. So I'm fairly confident that one's going to be okay. Alright, so that's it. That's our way cool way covers fitted to the Bridgeport. And remember, if you're thinking about doing this from scratch, I would almost certainly get rid of these flimsy strips of stainless steel that come with these Chinese concertina covers. Fit something a little bit more substantial like that. Now, in the next video, I'm going to show you how to fit a scale to this section of the Bridgeport column and knee, and I've got a rather unique way of doing that, so check that out. And we're going to come back and look at the touch DRO system and see some practical applications for that. So for now, thanks for watching. I'll catch you on the next video. It's Prezzo signing out.